When the clock struck midnight on May 8th, 1945, something unprecedented happened across the shattered landscape of Europe. Nazi Germany, the most militarized state in human history, had finally surrendered. But the end of the war created a problem no nation had ever faced before. Scattered across the continent, from the Norwegian fjords to the Austrian Alps, from the beaches of Normandy to the ruins of Berlin, lay the largest arsenal of weapons ever assembled by a single power. Over 25 million rifles, hundreds of thousands of machine guns, tanks numbered in the tens of thousands, artillery pieces that could fill entire valleys, aircraft, submarines, rockets, and experimental weapons that seemed pulled from science fiction. The question facing the Allied powers was simple to ask, but impossibly complex to answer. What do you do with the weapons of a defeated empire? This wasn't just a logistical challenge. These weren't merely tools of war waiting to be cataloged and stored. They were symbols of a regime that had brought the world to its knees, instruments that had enabled genocide and conquest on an industrial scale. Every rifle carried the weight of history. Every tank bore the scars of battles fought across 3 continents. And now, as the smoke cleared and the world began counting its dead, these weapons sat silent, waiting for someone to decide their fate. The scale of what the Allies had captured defied comprehension. In warehouses from Hamburg to Munich, rifles stood stacked floor to ceiling, arranged in perfect geometric rows that stretched into darkness. Rail yards across Germany had become impromptu storage facilities, with train cars filled to capacity with ammunition, small arms, and equipment. In open fields, tanks sat parked in formations that extended beyond the horizon, their armor still bearing the marks of combat, their fuel tanks empty, their crews long since vanished into prisoner-of-war camps or unmarked graves. The numbers tell part of the story, but they can't capture the sheer physical presence of this arsenal. Over 25 million small arms included everything from the standard Karabiner 98 Kurz rifle that had armed German infantry since before the war, to the revolutionary Sturmgewehr 44, the world's first true assault rifle. More than 46,000 armored vehicles included not just the famous Tigers and Panthers that had terrorized Allied tankers, but thousands of lighter tanks, self-propelled guns, armored cars, and half-tracks. Around 100,000 artillery pieces ranged from small mortars to massive railway guns that could hurl shells weighing several tons. The Luftwaffe had left behind thousands of aircraft, many of them advanced designs that the Allies had never seen in combat. The Kriegsmarine submarine fleet, once the terror of the Atlantic, now sat moored in harbors under Allied guard. Over 150 U-boats that represented the cutting edge of underwater warfare technology. Allied military planners found themselves overwhelmed by the magnitude of the task. British, American, French, and Soviet forces each controlled different zones of occupation, and each zone contained massive stockpiles of weapons. In some areas, entire forests had been transformed into open-air storage depots, with tanks and artillery pieces parked beneath the trees like mechanical wildlife. Underground bunkers and fortifications held ammunition in quantities that seemed impossible to quantify. Factory complexes still contained partially assembled weapons, raw materials, and machinery capable of producing more. The Allies faced a choice that would shape the post-war world: what to do with this unprecedented arsenal. The immediate Allied response was driven by a single, urgent priority: denazification and demilitarization. Germany could never again be allowed to threaten world peace. The weapons that had enabled Nazi conquest had to be eliminated, controlled, or rendered harmless. From occupation headquarters across Germany, orders went out. Every weapon was to be collected, cataloged, and sorted. What couldn't be used would be destroyed. What had value would be seized. The process began almost immediately, even as the last shots of the war were still echoing across Europe. Destruction came in many forms, each as brutal and final as the war itself. In fields outside bombed-out cities, soldiers used captured German rifles as kindling for bonfires, watching as wood and metal warped in the flames. Tanks were stripped of anything valuable, then driven to designated areas where demolition teams rigged them with explosives. The detonation sent plumes of black smoke into the sky, turning precision-engineered armor into twisted scrap metal. Machine guns were crushed beneath the treads of Allied tanks or fed into industrial crushers that reduced them to component parts. Ammunition dumps were particularly problematic. German forces had stockpiled millions upon millions of rounds in bunkers and warehouses across the country. The safest solution was often the most dramatic. Pack the bunkers with additional explosives and detonate them from a safe distance. The resulting explosions could be heard for miles, and some burned for days, sending continuous streams of secondary detonations crackling into the sky like deadly fireworks. But perhaps the most dramatic example of Allied destruction was Operation Deadlight, a mission specifically designed to eliminate Germany's formidable U-boat fleet. Of the 156 U-boats that surrendered to Allied forces at war's end, 116 were earmarked for destruction. The Royal Navy took responsibility for this massive undertaking, planning to tow the submarines to designated areas roughly 100 miles northwest of Ireland, where the Atlantic depths would claim them forever. The operation officially began on November 17, 1945, and immediately encountered problems that would plague it throughout its duration. Many of the U-boats were in terrible condition. They had spent months moored in exposed harbors, battered by weather and neglect, their sophisticated systems corroding from lack of maintenance. Some were barely seaworthy. Winter weather in the North Atlantic added another layer of danger to an already hazardous operation. High seas and gale-force winds made towing treacherous. Tow lines snapped. Submarines took on water and foundered before reaching the scuttling zones. In the end, 56 of the U-boats sank while being towed to their designated destruction sites. Those that did reach the scuttling areas were sent to the bottom by various means: naval gunfire, aerial bombardment, or torpedo attacks from other submarines. The last U-boat, U-3514, received the distinction of being the final vessel sunk in Operation Deadlight when it slipped beneath the waves on February 12, 1946, at precisely 10:04 in the morning. The operation had taken nearly 3 months and disposed of vessels representing billions of man-hours of engineering and construction. They now rest on the ocean floor, slowly corroding into the sediment, their steel containing no radioactive contamination from atomic testing, making them paradoxically valuable to modern researchers who occasionally consider salvage operations. But destruction was only half the story. Even as tanks were being blown apart and rifles were being melted down, another race was underway, one that would shape the technological landscape of the Cold War. Both the United States and the Soviet Union had realized something crucial. Germany hadn't just built more weapons than anyone else. They had built better weapons, weapons that represented technological leaps beyond what the Allies had achieved. German scientists and engineers had pioneered jet propulsion, ballistic missiles, advanced optics, sophisticated submarine designs, and weapon systems that seemed decades ahead of their time. The race to capture this technology began even before the war ended, and it was conducted with an urgency that bordered on desperation. The United States launched Operation Paperclip, one of the most controversial programs in American history. Initially called Operation Overcast, the mission was straightforward: identify, locate, and recruit German scientists, engineers, and weapons designers before the Soviet Union could claim them. Teams of American intelligence officers fanned out across occupied Germany, armed with a crucial document: the Osenberg List. This catalog of German scientific and technical personnel had nearly been destroyed when German officials, panicking as Allied forces advanced, attempted to flush it down a toilet at Bonn University. The partially destroyed documents were recovered and became the foundation for American recruitment efforts. The program's name came from the paperclips attached to the dossiers of scientists whose Nazi Party affiliations or war records were considered problematic, marking them for special consideration despite President Truman's explicit orders forbidding the recruitment of active Nazis. or Nazi supporters. Over the course of the operation, which officially lasted until 1947 but continued in various forms until 1962, roughly 1,600 German scientists, engineers, and technicians were brought to the United States. The most famous among them was Werner von Braun, the technical director at Peenemünde who had led development of the V-2 rocket. Von Braun and his team arrived at Fort Bliss, Texas, in September 1945, bringing with them knowledge that would directly influence American missile development, jet aircraft design, and eventually the space program that would put Americans on the moon. The moral implications were staggering and remain controversial to this day. Many of these scientists had worked closely with the Nazi regime. They had overseen factories that used slave labor from concentration camps. They had developed weapons specifically designed to terrorize civilian populations. But American military leaders, driven by Cold War paranoia and the fear of Soviet technological superiority, chose to overlook these crimes in the name of national security. The Soviet Union conducted its own program with characteristic ruthlessness and efficiency. Operation Osoaviakhim, launched on October 22, 1946, was unprecedented in its scale and audacity. In a single, coordinated operation, Soviet forces moved through their occupation zone in Germany, identifying and essentially kidnapping thousands of German specialists, along with their families. Entire factories were dismantled, with machinery, tools, and production equipment loaded onto 92 freight trains bound for the Soviet Union. The Mittelwerk underground factory, where V-2 rockets had been produced, was literally transplanted to Soviet territory. Piece by piece, German engineers and scientists found themselves relocated to Soviet research facilities, sometimes for years, working on projects that would give the USSR its own ballistic missile program, advanced jet designs, and weapon systems that would define Soviet military capability for decades. The technological legacy of captured German weapons extended far beyond individual scientists or specific designs. Both East and West carefully studied German armor, and the lessons learned influenced tank development for an entire generation. Soviet engineers examined captured Panthers and Tigers, noting the sloped armor that deflected shells more effectively than flat plates, the powerful guns that could penetrate Allied armor at unprecedented ranges, and the sophisticated crew layouts that maximize combat efficiency. These observations directly influenced post-war Soviet tank design, with vehicles like the T-54 and its successors incorporating design elements that originated in German drawing rooms. Western powers engaged in similar studies, testing captured German tanks extensively and incorporating the lessons into their own armored vehicle development programs. German jet technology represented perhaps the most significant technological transfer. The Messerschmitt Me-262 had terrified Allied pilots late in the war, demonstrating speeds and capabilities that conventional propeller-driven aircraft simply couldn't match. After the surrender, both the United States and Soviet Union scrambled to capture Me-262s and the scientists who had designed them. Extensive testing revealed the secrets of swept-wing design, advanced engine technology, and aerodynamic innovations that had given German jets their edge. American jet development in the late 1940s and 50s drew heavily on this captured knowledge. Soviet jet programs benefited similarly, with captured German research accelerating their own development efforts by years. While destruction and technological appropriation grabbed headlines, millions of German small arms followed a different path: redistribution. The Soviet Union, responsible for occupation of Eastern Germany, and with enormous influence over the emerging communist governments of Eastern Europe, began a systematic program of distributing captured German weapons to ideologically friendly forces. Polish security services received thousands of German rifles and submachine guns. Czechoslovakia's new communist government armed its forces partly with captured German equipment. East Germany's own paramilitary police forces initially carried weapons that bore German markings from a regime they were supposed to be renouncing. The iconic MP-40 submachine gun, the Karabiner 98 Kurz rifle, and the legendary MG-42 machine gun all found new life in the hands of communist forces. Communist resistance. Movements around the world became recipients of this largesse. In countries where communist parties were fighting for power or conducting insurgencies, Soviet-supplied German weapons provided crucial firepower. The weapons were reliable, ammunition was plentiful from captured German stocks, and they were effectively free from the Soviet perspective. A weapon didn't care who held it, or what ideology guided its use. A Mauser rifle could serve fascism one year and communism the next, with equal efficiency and without moral qualm. German weapons also found their way to the Middle East through various channels, both official and clandestine. Arab armies in the 1950s and 60s carried equipment that bore German markings and design characteristics. Some of this equipment came through Soviet intermediaries. East Germany, despite its tiny population and limited industrial capacity, provided approximately 3% of Soviet bloc military supplies to Middle Eastern nations during the 1950s through the 1970s. While this represented a small percentage, it was still sufficient to arm significant formations. German small arms, including rifles and machine guns, appeared in conflicts across the region. The weapons were durable, well-designed, and familiar to soldiers who had trained on similar equipment. The Sturmgewehr 44, Hitler's revolutionary assault rifle that had been produced in the final years of the war, embarked on perhaps the most remarkable journey of any German weapon. Despite being manufactured for only about 2 years, approximately 400,000 were produced. These weapons didn't simply disappear when Germany surrendered. They were seized by Soviet forces, redistributed to client states, sold or given to resistance movements, and gradually dispersed across the globe. In the 21st century, Sturmgewehr 44s have been documented in conflicts in Syria, Afghanistan, and various African nations. The sight of a weapon designed in the early 1940s still being used in combat operations 80 years later speaks to both the durability of German engineering and the long half-life of military equipment once it enters global circulation. Beyond seizure and redistribution, Allied powers engaged in extensive programs of study and reverse engineering. Captured German equipment didn't just influence new designs, it was carefully dissected, tested to destruction, and analyzed for any advantage it might provide. British engineers examined German tank optics, which were superior to British equivalents. American ordnance experts tested German artillery, measuring range, accuracy, and mechanical reliability. Soviet designers studied everything from German small arms mechanisms to advanced submarine designs. Testing facilities across the Allied nations became repositories for German equipment, where teams of engineers and scientists subjected captured weapons to rigorous examination. The influence of these studies was often subtle but profound. A German innovation in gun barrel rifling might show up years later in American small arms. Soviet tank transmissions incorporated design elements originally developed by German engineers. Western jet engines benefited from German metallurgical advances and combustion chamber designs. The knowledge transfer was rarely direct, but it was extensive and consequential. German weapons had lost the war, but German weapons technology would influence military hardware for decades to come. Not everything was accounted for. Despite the massive Allied efforts to collect, catalog, and dispose of German weapons, significant quantities simply vanished. Across Europe, weapons were hidden in caves, buried in forests, secreted in abandoned mines, or concealed in buildings that would later collapse or be demolished. Some of these caches were deliberate, prepared by fanatical Nazi holdouts who believed resistance would continue. Others were simply lost in the chaos of surrender and occupation, weapons abandoned by fleeing soldiers or overlooked by overwhelmed Allied recovery teams. To this day, construction projects, farming operations, and forest management activities across Europe regularly unearth World War II-era weapons and ammunition. Unexploded ordnance kills civilians decades after the war's end. In Germany alone, bomb disposal experts continue to defuse or safely detonate tons of unexploded munitions every year. Rivers and lakes occasionally yield weapons that had been thrown into the water during the final days of the war. Building demolitions in former combat zones still sometimes reveal hidden weapons caches. Each discovery is a reminder that the war's physical legacy persists, buried but not gone, dangerous and unpredictable. The disposal of chemical weapons created an environmental catastrophe whose consequences are still being discovered. Germany had stockpiled massive quantities of chemical weapons during the war, including mustard gas, nerve agents, and arsenical compounds. After the surrender, Allied forces faced the challenge of safely disposing of these extremely hazardous materials. The solution adopted was deeply flawed: ocean dumping. At least 32,000 tons of chemical weapons, including approximately 400,000 bombs and rockets filled with mustard gas and other agents, were loaded onto ships and dumped into the Baltic Sea and other bodies of water. At the time, this was considered safer than attempting to destroy the materials on land. The assumption was that the weapons would sink into deep mud on the ocean floor and remain largely harmless. Modern research has revealed this assumption to be tragically wrong. Studies of dump sites in the Baltic Sea have found that chemical agents have been leaching from corroding munitions. Fish and sediment samples show contamination with sulfur mustard, arsenical agents like Clark-1 and Adamsite, hydrogen cyanide, and tear gas components. The Baltic ecosystem, already fragile, is being slowly poisoned by weapons dumped 80 years ago. The casings that contain these chemicals are failing, their integrity compromised by decades of saltwater corrosion. The full environmental impact remains unclear, but evidence suggests the problem will worsen as more casings fail in the coming decades. Similar dumps exist off the coasts of Norway, Sweden, and Denmark. The legacy of German chemical weapons is quite literally buried at sea, waiting to resurface. By the late 1940s, the world faced a profound contradiction. Germany remained officially forbidden from possessing a military. The Allied occupation explicitly prohibited German rearmament, but the geopolitical landscape was shifting with alarming speed. The Soviet Union, once an ally, had become a potential adversary. The Iron Curtain had descended across Europe. Western Europe needed defense, and the question of German participation in that defense became unavoidable. The knowledge embedded in German military tradition, the lessons learned in years of combat, and the industrial capacity that had once armed the Wehrmacht couldn't simply be ignored in the face of the Soviet threat. West Germany's rearmament began slowly, cautiously, within strict parameters. The Bundeswehr was established in 1955, but only as part of NATO, ensuring that German military power would be subordinated to alliance command structures. Interestingly, some of the equipment that armed the early Bundeswehr came from the United States, which provided weapons through military assistance programs. Former Kriegsmarine ships that had been seized by the Tripartite Naval Commission were returned by the Americans. West German officers began training on American vessels, a reversal of fortune that would have been unthinkable just a decade earlier. The new German military was explicitly designed to operate within an alliance framework, a dramatic departure from the independent and aggressive military tradition of previous German states. The weapons themselves had not vanished in 1945. They had transformed, dispersed, and persisted in forms both obvious and subtle. They had fueled the technological race between superpowers. They had armed new conflicts in distant lands. They had shaped the development of post-war military equipment across the globe. And in some cases, they still physically existed, either buried beneath European soil, rusting on ocean floors, or, remarkably, still in service in the world's conflict zones. The story of German weapons after 1945 is ultimately a story about the persistence of violence and technology beyond the conflicts that created them. Wars end, armies surrender. But the tools of war have a strange and troubling longevity. A rifle designed in the 1930s can still kill in the 21st century. A tank built to conquer. Europe can end up rusting in a Middle Eastern desert decades later. Technology developed by one regime can serve its bitterest enemies. The knowledge acquired through violence can be repurposed for new forms of violence in new contexts. When Germany surrendered in May 1945, it seemed like an ending. The largest war machine in history had been defeated, dismantled, and destroyed. But it wasn't an ending at all. It was a transformation. The weapons were destroyed, studied, reused, repurposed, hidden, and forgotten in roughly equal measures. They fueled the early Cold War, providing both sides with technological advantages that accelerated the arms race. They shaped modern military design in ways both obvious and subtle. They continue to surface in conflicts around the world, tangible links to a war that ended before many current combatants were born. Today, somewhere beneath European soil, steel from a forgotten war still waits. In museums and collections, German weapons sit preserved behind glass, silent witnesses to history. In war zones from Syria to Afghanistan, weapons designed by long-dead German engineers still function, still kill, still serve purposes their creators never imagined. The end of a war doesn't end its weapons. It only changes their owners, their purposes, and sometimes their targets. The arsenal that Germany surrendered in 1945 didn't disappear. It simply found new wars to fight, new hands to hold it, and new purposes to serve. The question of where all those weapons went has many answers, and the final chapter of their story has yet to be written. If you found this deep dive into the hidden aftermath of World War II fascinating, make sure to like this video and subscribe to WW2 Tales. We're constantly uncovering the forgotten stories, the hidden consequences, and the lingering mysteries of the world's greatest conflict. Because history isn't just about how wars begin, it's about what they leave behind, and those legacies shape our world in ways we're still discovering. Thanks for watching, and I'll see you in the next one.